You're welcome to another video of Yang-based network automation using netconf, restconf, and GNMI. In the previous section, we have changed the configuration of network devices through configuration data in the format of JSON and in restconf protocol. But the problem is that JSON configuration data is difficult to change and to keep in a large scale network, and in this section, therefore, we will use YAML based configuration data, which is much easier to be changed and work. We will use load YAML from nornir utils Python library to load YAML configuration data and keep it in a JSON dictionary structure, which can be directly uploaded to the network devices. In fact, it is not easy to keep the configuration data in XML or JSON format, and the easiest way to store the configuration is in the format of YAML. But what is actually the acceptable format of the configuration to be sent to the network device is XML and JSON format. We will use Python load YAML from nornir utils, which has the capability to change the YAML configuration data to JSON format, which can be sent to network devices directly. The question is how we prepare the configuration data in the format of YAML, and then how we prepare the final configuration data again in the format of JSON. What we receive as the output of the configuration from network devices are in the format of JSON. Then we can use the JSON to YAML online services like json to yaml.com to convert JSON configuration of network devices to the YAML format. Then it is much easier to edit, change, and keep the configuration in the format of YAML. Finally, again, we use load YAML from nornir utils Python library to convert the YAML-based configuration data again to the JSON format before sending to the network devices. In the first step, let's check how we convert and keep the configuration in the format of YAML. As examples, we get sample configuration of OSPF and BGP of a network device, and then we convert it to the YAML using JSON to YAML online service. This is done using the script that we already discussed in the previous section, the script 13.3 restconf with Python request. Let's check inside it. I will choose the URL related to the OSPF configuration, and then we run the script to get OSPF part of the configuration, which is URL 5. Let's change the URL in the request command to the URL 5. And we run the script Python 13.3. This is the output of the OSPF configuration in the format of JSON, which we are going to convert to the YAML. When we try to convert the OSPF output in the format of JSON to convert it to the YAML, we receive error. By default, the JSON output uses single quote, and we need to change all single quote to the double quotes before trying to convert it to the YAML. Here, for example, if I change to the double quote, the error will move to the another section. The all single quotes has to be changed to the double quote. It can be done using set command to change all single quote to double quotes. Then the output can be easily converted to the YAML using JSON to YAML web service. In the history, I will check for the command set, and again I will use the set command to change all single quote to the double quote. Copy and then paste. As you see in the output, all single quotes are converted to the double quote. Again, I will use the output in the online service to change it to the YAML format without receiving any error. This is the sample OSPF configuration in the format of YAML, which can be edited and stored for further processing and uploading to the network devices. To see another example, let's receive and convert the BGP configuration of network devices. We change the URL to point to the BGP part of the configuration. In our example, URL 12, as you can see, is pointing to the BGP configuration. Therefore, I will change here the URL to URL 12 and again save and run the script. The output again is a single quote, and again I use the set command to change all single quote to double quote. And then I will copy the BGP configuration in the format of JSON to convert it to the YAML. Still, I receive error in the true section, for example, and this is because the value like true and false also must be in a double quote, and I receive no more error. And this is the output of BGP configuration, sample BGP configuration in the format of YAML, which can be edited for sending and uploading to the network devices. Therefore, this is a method that we can use to change any part of the configuration to the YAML format and keep the YAML format of the configuration data. And it is much easier to change and extend the configuration. And again, we can use the load YAML from nornir utils Python library to change it to the JSON format before sending to the network devices. This is the script that I have already prepared to change the configuration of network devices via YAML-based configuration payload instead of normal JSON configuration payload. You can see in the header of the script that in addition to the Python libraries request and nornir that we used in the previous section, here we add the task load YAML from nornir utils Python library, which is responsible for loading the YAML based configuration data and preparing the JSON configuration payload, which can be uploaded directly to the network devices. With the function load data, we are loading the YAML based configuration data, which is already stored in the folder host_vars. For each network device, we store the configuration data in a file with the name of device itself. The loaded data is stored in a dictionary structures with the name of device itself and hdata as a key or any other variable as the key. If we check inside the YAML base configuration data host_vars and r1.yaml in the router r1, we see the sample configuration of OSPF and then NTP and then access lists. We just discussed how to extract YAML based configuration data from any part of the network configuration. We have already showed the OSPF and BGP configuration. The NTP and access list configuration is also prepared using the same method. Here I have used a key for each part of the configuration to be used as the dictionary key to access the configuration data. the keys OSPF config, NTP config, and ACL config are used in order for OSPF, NTP, and access list configuration. Looking again at the script, we see that these keys are used along with hdata to access each part of the configuration. For example, the key sequence hdata OSPF config is used to access the network device OSPF configuration inside the dictionary structure. The key structure hdata NTP config and hdata ACL config are used to access the NTP and access list configuration of network device in dictionary structure. The output of the loaded configuration data along with the corresponding URL is used to upload the configuration through restconf.put command. Therefore, for each part, we will use the corresponding URL for OSPF, for NTP, and for the access list, along with the configuration data in a JSON format, and with the command request.put to upload it to the network device. Now let's run the script and see the result of the new configuration in output of the script and also in the network device. If I run the script 13.6, you see that all three configuration payload are successful because of the code 204. We can also check in the network device itself to make sure that the configuration is correctly changed. Check the configuration, show running config, section, router, OSPF, or access list, or NTP. You see the configuration of OSPF is changed, and access list and NTP configuration are also added to the network device.